And welcome to Mrs. Riley's Maths videos. This is a video introducing the topic of counting and permutations, which is also sometimes called choices and arrangements. It used to be called permutations and combinations in the old day, but basically it's kind of connected to probability, and it's all about working out how many different outcomes there can be when different things happen. We covered in junior cycle and we covered in leaving cert, and I'm just going to go over some of the basics that you learnt in junior cycle, which is the start off anyway of our chapter that we're looking at here, chapter 11 in active maths 3. So here's a couple of things that maybe will jog your brain. Here's a suggested situation. You've got a lunch menu. You've got 3 starters as options. You've got soup, garlic bread and salad. You've got a main course. You could choose from pizza or burger and chips or pasta and pesto or a baked potato and chili. And then there's 3 desserts to choose from. So each of these has what? Starters, there's 3. Main courses, there's 4. And ice cream, there is 3. So how many different possible meals could be chosen there? And could you list all those meals? And could you make sure that you had managed to list every single possible meal and not just some of them? Here's another example. If you roll a dice and toss a coin, how many possible outcomes are there? Could you list them all and be sure you had got them all? And then finally, if you were to roll 2 dice, 1 red dice and 1 blue dice, could you list all the possible outcomes you could get, and how many would you get? So that's the type of question we're looking at. I'm videoing this at night, sorry, in the evening, so the light's not going to be great, but hopefully it'll be good enough for you to see what's happening. So take a moment, just pause the video if you like and think, how would you answer those questions? Okay, now hopefully you've paused it and given it some thought before I launch into my solution here. So we've got 3 starters, 4 main courses and 1 dessert. We want to make sure we get one of each in all our different possible meals. So we might do something like write down, okay, we're going to have soup, and then we're going to have pizza, and then we're going to have ice cream. Ice cream. Okay, and then we could have soup, burger, and ice cream. Okay, so you know there's 2 meals already with different starter, main course and dessert. Of course that's going to take a long time, and unfortunately some of these do take a long time, but we'll find out that there is a couple of ways that we can do that actually make sure we're a bit systematic in how we do it, and that we can make sure we cover all the options, and we won't always have to list all the options, so that's useful. One of the ways, and I'm not going to be able to complete the full example here, but one of the ways that we use to list all the possible outcomes is what's called a tree diagram. Now, not to be confused with a stem and leaf, which is in statistics, but a tree diagram. So what does that look like? What that says is that we would say we'd have a column here we'd call a starter, and we'd say soup, garlic bread and salad. Now if we have soup, there are 4 possible main courses we could have. Main courses. We could have pizza. We could have burger. We could have pasta. And we could have, let's say, chili. We'll call it chili. Now if we had soup and pizza, we can still choose 3 from 3 desserts. So we could have ice cream, we could have chocolate cake, and we could have fruit. So if you notice here, this diagram here, if I do the next one for burger, now because I've already used ice cream there, I could just write I for ice cream, C for cake, and F for fruit. For pasta, I could have ice cream, cake or fruit, and for chili I could have ice cream, cake or fruit. Now if you notice, each of these kind of trails is an option. So I've got soup, pizza, ice cream. Soup, pizza, ice cream. I've got soup, pizza, chocolate cake. Soup, pizza, cake. I've got soup, pizza, fruit. Soup, pizza, fruit. I then have soup, burger and ice cream. I have soup, burger and cake. soup, burger, cake, soup, burger, fruit. Then I have soup, pasta and ice cream, soup, pasta and ice cream, soup, pasta and cake, soup, pasta, cake, and soup, soup, pasta and fruit, soup, pasta and fruit. And if you notice, each of these lines is giving me a different meal option, and I can do the same for garlic, pizza, burger and chili. Now, and pasta, I forgot pasta there. Now, as you can see, it takes up a lot of space and it is slow. But if I wanted to make sure I was going to cover all the options, that is how I could go about it. Now, we will look in the next class, we'll look at how would you work out how many possible combinations there are for the meals, and maybe you've worked that out already. Maybe you already know how many different possible meals you can have. You'll get an idea here, because already with soup, soup, pasta, we'll just finish this off, soup, pasta, fruit, and then we have soup, chili, ice cream, soup, chili, and cake, and soup, chili, and fruit. So for soup alone, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 options that are just start with soup. So you might already have a clear idea as to how many possible options there are altogether. There are in fact 12 for soup, 12 for garlic bread, and 12 for salad, so there's 36 altogether. If you roll a dice and toss a coin, how many possible outcomes are there? So you roll a dice and toss a coin. So let's think, when you roll a dice, there's 2 possible outcomes. You can get a head or you can get a tail. No, you don't. That's for a coin. When you roll toss a coin, you can either get a head or a tail. When you roll a dice, you can get a 1, a 2, a 3, a 4, a 5, a 6. We could use a tree diagram for this as well. So we could use a tree diagram, and we could say head 1, head 2, head 3, head 4, head 5, head 6, and tail 1, 2, 3, 4, 5, 6. In other words, we've got a head and a 1, a head and a 2, a head and a 3, a head and a 4, a head and a 5, a head and a 6, a tail and a 1, a tail and a 2, a tail and a 3, a tail and a 4, a tail and a 5, a tail and a 6. So that's one way we could do it. We could also use what's called a two-way table, which is something like this. Okay, in the two-way table we have head and tail here, and here we'd have 2, 3, 4, 5. So we'd have 1, 2, 3, 4, 5, 6. So this is our dice, this is our coin. So here, this box here would be a head and a 1, or a 1 and a head on the coin and a 1 on the dice, or a 1 and a tail, a 1 on the dice and a tail on the coin. Here would be a 2 on the dice and a head, a 3 on the dice and a head, a 4 on the dice and a head, and so on. So you can see it actually looks a bit easier to do than the tree diagram. Obviously it wouldn't work for the menu because there's just too many options there. 3 tail, 4 tail, 5 tail, and 6 tail. And again, that does the advantage of it tells us all the different options listed easily, and as you can see there are 12 outcomes. When we toss a coin and roll a dice, that's called an experiment. Okay, so this is an experiment, as is choosing a menu. That's an experiment. Okay, a trial is a word that's used to describe when we do one of those experiments. Okay, let's just turn over the page. So here's our third experiment. If you roll 2 dice, 1 red dice and 1 blue dice, list all the possible outcomes you could get. Listing all the possible outcomes you get is called listing the sample space. So we've had outcomes, we've had experiment, we've had trials, we've had tree diagrams, and we've had two-way tables. I'm going to use a two-way table for this. Another one. So here's my table. I need it to be a square this time because 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, and 6. So this is going to be my red dice. So I could get a 1, a 2, a 3, a 4, a 5, or a 6 on the red dice, and this is going to be my blue dice. 1, 2, 3, 4, 5, 6. So here my outcomes would be a 1 and a 1, a 1 and a 2, a 1 and a 3, 1 and a 4, 1 and a 5, 1 and a 6. That means I got 1 on the red dice and 6 on the blue dice. A 2 on the red, a 1 on the blue, a 2 on the red, a 2 on the blue, a 2 on the red, a 3 on the blue, and so on. So for instance, if I had a 5, 6 here, it means 5 on the red dice, blue on the 6 on the blue dice. And as you can see, there'll be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 6 times 6, 36 possible outcomes. Okay, so in summary, we've got some keywords here. We've got an experiment, which is something like tossing a coin and rolling a dice. We've got sample space, which is where we're listing all the possible outcomes. We have a tree diagram, which is one way of listing all the possible outcomes. And we have a two-way table, which is another way of listing all the possible outcomes. Okay, it's not difficult. The questions do get a little bit harder, but not much harder than that. And if you'd like to try the exercise now that I've asked you to do today for class. Thank you.